Okay, good evening. Welcome to
AwesomeMath number 78.
AwesomeMath78. So we started our section on modular arithmetic today, which is a really fun piece of math. So the way they introduced it was with clocks.
Yep.
How many hours would you like to have on a clock?
Let's have 6 hours.
6 hours. Okay, so our clock is going to have a 6, just like our normal clocks have a 12. And go 1, 2, 3, 4, and 5. Okay?
But don't you have a 0?
Well, what would be the equivalent of 0 on this
That would
clock?
be 6.
That would be the 6. 6 and 0 would be the same.
Yeah.
Would you prefer to call it 0, or would you rather call it 6?
That would be fine with 6.
Okay, so let me ask you. If we started here and 3 hours went by, where would we be?
You would be at 3.
Okay. If 6 hours went by, where would we be?
We would be all the way around 1, 2, 3, 4, 5, 6. We would be back at 6.
If 8 hours went by, where would we be?
Well, we would be at 2 since we have to add 2 more hours to that.
Interesting. So in this arithmetic, 8 plus 6 equals what?
8 plus 6 is, well, it would be 2.
2. That's interesting.
Yeah.
What is 10 plus 10?
Well, 10 would be a 4, so it would be a 2 again.
Well, this is a weird clock. Maybe everything's equal to 2.
Well,
But, do you want to do one? Make one up in addition?
Let's try 5 plus 10.
5 plus 10.
5, and then 10 you go around 1, 2, 3, 4. So it's not everything is equal to 2.
Phew, not everything's equal to 2. Now, you can also subtract.
So you could, so once you reach 6, you have to go shift back to 5, 4, 3, 2, 1.
Yeah.
And
So let's do 8 minus 1. What does that equal?
well, 8 would be here, so 8 minus 1 would be 1.
That's interesting. 8 minus 1 equals 1. What is 4 minus 6? Ha ha.
4, 1, 2, 3, 4, 5, 6. So we're back at 4. 4 minus 6 is 4.
4 minus 6 is 4 in this clock.
Nah.
All right, you make one up.
Let's try 1 minus 7.
Wonder what that's going to be.
1, 1, 2, 3, 4, 5, 6. So a 6 or a 0.
Huh. We can say 6. 1 minus 7 equals 6.
On a normal clock, 7 minus 1 would be 6.
Do you think you can multiply?
Well, you just, if you had like 2 times 3, all you have to do would be 1, 2, 3, 1, 2, 3, 1, 2, 3. So you can multiply, it's just like adding.
Wait, I'm a little confused as what you did on the multiplying.
So
2 times 3. What did you do?
we could either do it, we could start at 6, so 1, 2, 3, 4, 5, 6.
Okay, that was
Oh, it was 2 times 3.
that was 2 times 3. Okay.
And then
What about 3 times 2?
that would be 3, 6.
Ah,
So, and it would be, it's like the same, but it's just the hours are different.
okay. One thing that's interesting about multiplying is we could multiply really big numbers together, like 20 times 41, by reducing them on the clock first. Like, where would 20 be on the clock?
20 would be at 2.
20 would be at 2. Where would 41 be on the clock?
41, well, that would be at 5.
At 5. So 20 times 41 is the same as 2 times 5, which is?
Which, it's 1, 2, it would be at 4.
4.
5 times 2 is 4.
That's interesting. Now, we're not going to get into it now, just because this was an introduction.
Yeah.
Do you think you can divide?
Well,
If 2 times 5 equals 4, that might mean 4 divided by 5 is 2.
Well, you could divide like 4 divided by into 2 groups. That would be 2.
Yeah, so division's a little harder,
Yeah.
but we'll get there. It's pretty neat though, modular arithmetic.
Yeah.
And doing things like this, going from high numbers to low numbers first, is a big part of it. All right, high five. Think you're going to like this chapter?
Yeah.
All right, good job, hon.